and a very good morning to all. I'm Srinivas and I'm the technical element lead in the data engineering team at Novartis. So, coming back to the topic, R, a contender for SAS in data analytics. Uh, if you look into the agenda, there is a core discussion point on SAS to R transition. We have seen the extensive usage of SAS in the pharma domain, and of course, it has been the undisputed software used in large enterprises for data analysis. However, it comes with a price, and with companies shifting towards the value-based models, either because of cost or some complexities, they are looking at R as an alternate code, and thus making R as a strong contender to SAS. And with the profound usage of SAS and the deep programming presence, it is obvious to think that the shift from SAS to R appears as a formidable task. So let us understand from a programmer, business, regulatory, and industry perspective as to how R is offering flexible and comprehensive language support that meets the current and future analytical needs. So before we jump into the discussion, I want to share an insight from the famous physicist Albert Einstein. Not everything that can be counted counts, and not everything that counts can be counted. I can put it in a different way. It is possible that not all data collected contribute to analysis, and sometimes the data that is not collected may become important. It is like evaluating a product with specific needs and evaluating the product, taking the feedback into the review. So this is quite evident in the e-commerce site like Amazon or Flipkart, where the customer reviews influence on the buyer's decision. So always look beyond what is available in the or what is available in order to make a meaningful information, and never miss to explore opportunities beyond the boundaries for making a rightful choice. So coming to the data analytics, the one-line definition for data analytics converting is nothing but converting data to information. So as you see in the slide, there are several types of data analytics, and they're not limited to what is presented here. Now, descriptive analytics helps us to answer what happened and what is happening in the context, and possibly prepare the data for further analysis based on the current results. Diagnostic, it helps to unearth or determine why something has happened, and it is mainly used in the social media campaign. And the prescriptive analysis is used to target specific questions, such as to manage the patient population by measuring the number of patients who are clinically obese and trying to understand what best treatment can be offered to them. Exploratory, by the name itself, it is something like performing experimentation and identifying the outliers. And predictive analytics is more to understand the likelihood of future results based on historical data. uh, we can see the implementation of predictive analytics in the oncology area, where we can see or predict the endpoint of a study based on the occurrence of a study event such as the PFS, the progression-free survival. So this is commonly applied there. And if you look into the mechanist or causal analytics, this is mostly used by the big scientists to understand what is change and what is the impact of the change. And inferential is more about how to relate results, like you have some parameters that have to be inferred to a large population based on the results that are seen in the small population. So coming back to the languages that support or that are used for data analysis. So SAS is one of the major language that is used. And if you look at the SAS features that are listed here, so these are the few of the many features that SAS offers. And if you want to choose the important ones from these, then the first one will be the strong analysis support. SAS provides end-to-end analytical support in generating descriptive statistics to advanced statistical models. The results are trusted and the package is widely accepted in the industry. And the second one would be the fourth generation language support, that is the English-like syntax, and which provides great convenience to the programmers in writing, following, and reviewing the code. And this convenience has been accepted by the user base. And the third one is it offers the robust and reliable platform for writing, reviewing, debugging, optimizing, and monitoring the performance of the program. And the strong user documentation and support enables the users quickly troubleshoot and ready the programs. And the important one and the last one that I can point out is the reporting capability of SAS. SAS has embedded strong reporting packages that make it more simple to generate a report in any format with the preferred layout. And of course, it has the strong support for graphs. But if you look at the implementation of SAS, the proprietary .7 SAS 7B DAT format is extensively used for storing large volumes of data. This is quite evident in all the clinical trials that we see nowadays. And it is extensively used in the data reviews for processing and transformation. And the XPT format is used for exchanging data between platforms and also used in submitting data to the health agencies that we can see in the format of XPT v5. That is a specific format that is recommended. And it is also used for pooling data sets for conducting integrated reviews and archiving data in the SAS format. And as discussed, SAS has a comprehensive analytical package that is used for generating any kind of analysis, and the strong reporting support enables the users in generating simple to complex report layouts and graphics. SAS macros are used in building standard reporting libraries like we see its common usage in deriving the fixed criteria like resist, and also it's sometimes used in determining or grading the toxicity grades for the lab events like CTC grading, and also coding templates can be built using the macros and the automation of routine tasks. Macros also enable in the defining of workflows of various tasks such as the data review and processing. And one of the implementation that we can see of SAS is the implementation of the global formats that can be applied at a project level or at an application level, which enables to maintain consistency in the data collection and also in the data reporting. And also SAS module support connecting to multiple data sources for data collection, like database, flat files, applications, and also is used extensively in extracting data to a common repository. And multiple formats like Excel, PDF, XML, JSON can be read and reported. That is one of the important features that is there with SAS. And also it provides integration with certain technologies. These are very specific, like it gets integrated with the VB and Visual VC++. And it's flexible architecture, like we have a client server architecture that is also available, and also it provides the grid networks which are custom built for high performance computing. Okay, and now we have seen SAS, and now R is also one of the major language that is used for the data analysis. And R is an open source software, and it is free to use. It can easily be downloaded and installed, and it has the easy syntax and can be learned easily by following the online documentation. There are packages available that can be used for interactive learning. So if you want to learn by installing the software and also the package and just load this package, then there would be some commands that would be telling you as to what you have to do, what commands you have to type. So that interactive learning is also there through the packages in R. And it also supports multi-platform, like it can be installed on Windows, Unix, Linux, Macintosh, and all other platforms. And it is a complete language like C++ and Java, and provides also the OOP support, that is object-oriented programming, wherein you can build classes and also create objects that can be instantiated for doing certain specific purpose. And like SAS, it offers the complete analytical support, and it consists of wide range of libraries which can be used for analysis and generating impressive graphics. And also the language flexibility of R allows extending functions and libraries, which will allow to develop even the custom libraries. And the development is shared in the community and enables other users to use the code and further customize and add more value. And so this allows R to be more innovative and add more packages to its kitty, and this extends the popularity of R. Our applications are also seen in the analytics and visualization field, wherein there are impressive graphic visualization that can be generated, and some of the famous packages are ggplot2 and ggvis, and also plotly, which are the packages that help in generating these graphics with less effort. and its application is seen in many companies, wherein we can see Google use it for calculating the return of investment on the advertisement campaigns, and Microsoft using it for Xbox matchmaking service, Twitter for statistical modeling for data science, and also Ford uses it for statistical analysis and integration with Hadoop. And Mozilla also uses it for uses R to visualize web activity. And also it can be seen in various domains like finance and banking, where the risk analysis and credit risk modeling can be done. So there are other domains which also use the analytical modules, and it is also seen in the data process in the healthcare industry, where it helps in performing the data processing, also generating certain reports and performing the data exploratory analysis. And it has got more capability in supporting the data mining, and we can see that the R itself is getting integrated to other applications like the R Shiny application, which provides extended service through the web platform. And R also helps in generating the ML algorithms or supporting more algorithms to be built. And it has got its own capability in getting called from a different technology or different language. At the same time, it can run through an API service and provide those services to other languages. So there are multiple ways R can offer services to uh, other technologies. Now, coming to the core discussion. Now, let us understand from a programmer perspective as to what capabilities or opportunities R is offering in shifting from SAS. So the first thing that comes to the mind of a programmer when a program is initiated is setting up the global environment. That is defining the file paths, data locations, and initializing the variables and running scripts, etc. This is quite easily done in SAS using the percentile include statements. I think everyone knows this. And the global declaration are added in another file, and this is called through the percentile include, and it is added at the beginning of the program, and that initializes the file. Similarly, R allows initializing at two levels. One is at a local level and one at a project level. So at a local level, there is support from .r profile. So the R profile is the environment build that is available in two paths. One in the path where the R application is installed, and the path where the program is running. So you can know the path using the r.home that will give you the path for the R profile site, and the R environment can be known using the R path.find, which will let you know as to at which path the program is currently running, and you can edit that and set up the global environment parameters. But this is at a local level. But if you want to implement it at a project level, then we have to follow the SAS process, wherein you define an R script, define the global parameters, and save that file and call it through the source program. So the functionality is almost similar to SAS. And both the languages provide the command line parameter processing. If you look at SAS, the sys parameter functionality is there, and same way, the args vector can be used to understand if there are any command line arguments that are passed with the our program. Next, after setting up the global environment, would be reading the data. And SAS, it is simple to read the data, the SAS and B data using the set statement. So the powerful set statement is to read data from multiple libraries, and also it helps in appending data vertically. R has got multiple packages. Heaven is just the one example that I have shown here, but we can see that there is another package, SAS7 BDAT, which can also be used. So it depends upon the functionality for which package has to be selected. So Heaven is well known in the industry, and that can be used to read the SAS7 BDAT format. And when other formats have to be used, both the programs or both the languages provide the same functionality that SAS provides the in-file and proc import functionality that can be read. And similarly, read.table or read.csv or read.delimiter, and there are other packages that are also available, which help in reading other formats, as I see, from a flat file or from a database or from an Excel. Now, the Other area which has to be looked on is the data formats. We have seen the excellent support that SAS provides in terms of defining formats, whether it is a picture format or whether it is a character or a numeric format. It can be easily generated and it can be used. And the formats can be saved in the SAS 7B cat, which is nothing but in a catalog mode or in a dataset format. SAS equivalent formats in R can be done, but there are workarounds that need to be created. Like you can create named vectors and can be called. You can call that, and also to some extent the R format function also provides some support. And also there is another function as printf which can be used for generating formatted outputs, and as printf is an extension to the C++. So it is also, so those who have a private understanding of C++, they can use that very easily. Dates, so there is a little bit of difference in terms of how the dates are captured in a numeric format. So the reference date or the zero date for SAS is the 1st Jan 1960, but in R it is the 1st Jan 1970. So to properly handle the data that is coming from SAS, we can use the ASDAT function, which actually by specifying the origin as the 1st Jan 1960 and the date component matches to the date that is being captured in SAS. And apart from that, the numeric operations are the same. So the date operations can be performed in both the languages. And apart from that, Lubridate is one of the package which offers extensive date operations in R. And also the format function enables to read and also to write data in multiple formats for dates. An interesting article published in Fuse describes the difference in the sorting and rounding between SAS and R. So R treats missing values as NA and sorts the numeric missing values as last in the order. So if we have some values with some missing values and with numeric values, then the numeric values would be first sorted, then the last records would be the missing values with the NA value. But when we look at the same sorting process in SAS, the missing values always will be presented as the first one. So this difference is there when you do the sorting, and this has to be taken care of at the time of data processing. And the second one that can be seen, the difference in the character sorting is the same, but it's only in the numeric sorting that the difference is seen. And the second one is the rounding off. So SAS uses the default rounding off of 0.5, wherein if there is a value of 1.5, either you make it to 2, or if it is 1.55, then it is the value that you nearestly round it out to 2. So, but R implements another algorithm called IEC 60559, according to which if there is any value that has to be rounded off, then it should be rounded off to the nearest even number. So if we take an example, like if you want to round 1.5, then the nearest even number would be the 2. So 1.5 would be rounded off to 2. And if you want to round 2.5, again, the nearest even number is 2. So it again rounds back to 2. So this difference is there. And there are the Fuse article provides an alternate workaround that can be used to have this rounding matched with the SAS functionality, and we can use that. So it's not that these limitations prevent from doing any kind of a processing in R. It's nothing, but it's just that we have to use the right workarounds to implement that. And similarly, first and last observation by grouping is also one of the important feature wherein it is commonly used in defining the baseline flags and other area. And the same functionality is offered in R using the DPL wire package, where the filter conditions allow to pick up the first and last row using the row number function. So the row number 1 would be the first record that can be picked up as which is equivalent to the first observation selected in SAS, and row number is equal to n is nothing but the same as the last record. And also the slice with the vector c of 1 of n, wherein you're passing the first record and the last record to be picked. That is also another way of selecting the first and last observation. And SAS also has this powerful functionality of transposing the records from long to wide format. Uh, and library and in R there are multiple libraries that support this functionality. The reshape2 and the tidyr have functions, the dcast and spread functions that can support long to wide functionality. And data sets also can be merged using the merge statement in the data set in SAS, and also the proc SQL helps in performing the data merge. But in R, there is no SQL functionality, but there is a supporting SQLDF package that can use that provides extended SQL functionality. And for performing the merge, there is a base function, which can have the merge base function that can be used to do the merge, and there are join functionality that is there from dplyr and data.table packages, which can be used to perform the same operation. And another observation to be noted is the differences of the default functionality in deriving certain statistics. If we look into the derivation of the quartiles using the proc univariate, so there is no specific method that is defined in the procedure. But when we try to define or derive the quantiles using the quantile function in R, the results that are produced if we don't pass any parameter is completely different to what SAS produces. So there is additional type parameter that has to be defined in R, and if the type parameter is set as 2, then the results exactly match to the SAS. So it is something that has to be noted, that if at all you're processing the data that is coming from a different source, there won't be any problem. But if at all you want to match the results that are produced in SAS and R, then we need to see that the exact type parameter is defined so that the results match to what is being produced in SAS. The next one is proc report combined with ODS functionality gives the powerful reporting edge that is used for customized reporting or complex reporting. So this is one of the greatest strength of SAS. And R also provides the same functionality. There are multiple packages that offer this kind of reporting layouts, like GT summary, the final fit, R markdown, officer, flex table. So there are many packages that provide similar functionality what R does, SAS does in terms of the proc report and the ODS functionality. Some additional processing would be needed to customize the reports in the same way what proc report does. When it comes to the graphic layouts, R has got excellent packages that we have discussed, like the ggplot2 or ggvis or the plotly, and the effort would be very less to generate these outputs. SAS also provides that, and SAS has got some template support, but sometimes the template tends to be complex. So there would be extra care that needs to be taken when the template definitions are derived for generating any graph in SAS. Now, SAS macros offer great flexibility in handling iterative functionality and developing utilities for general purpose. The macros can be easily written, and the debugging functionality, such as the options that are there, mprint, symbology, and mlogic, they help in debugging the macros, and these are the most friendly for a person who wants to see as to what is the flow in which the data is being interpreted while processing the macro, and also understand what are the values that are getting assigned to the variables which are being declared or initialized in the macro definitions. So in R also, the same kind of macro functionality can be defined or generated using functions and iterative loops. Functions are the one that are preferred because iterative loops do have some performance impact. So if there is large iteration that needs to be done, then it tries to block the resource, and sometimes it freezes the functionality. So it's better that always look for functional options. And at the same time, our base function apply has an optimization process wherein we can avoid certain looping conditions and directly use this apply function for specific processing. And also SAS platform enables efficient debugging. The log messages not only trace the execution of the program, but provide an important evidence for any audit or inspection. Errors, warning, other messages highlight the steps where issues are encountered and provide an easy way to address them. Such similar R functionality or package is not available, but using R complete language features, such functionality can be extended to the reporting modules. Uh, Glimpse can be used to some extent, and debug, traceback, and browser can be also used for code review. The dataset also can be compared using different libraries that are there, like CompareDF, dataset compare, R, and Arsenal. Arsenal is considered as one of the powerful package that can enable comparing the data frames. And we know the proc compare functionality in SAS that provides the same functionality. So either way, in the debug process, there are ways to understand the program and run the program and debug the program in R. But SAS has got a standard way of providing feedback to the user through the log messages. Now that we have seen the utilization of R or the capabilities that R offers from a programmer perspective, so let us understand from a business perspective as to what benefits R offers. First thing, cost has been the driving factor for many companies for opting alternate solutions. So SaaS comes with various licensing options, and there is an annual licensing cost attached to it. The cost of operation is substantial, and there is always the risk of vendor lock-in. And R, on the other hand, is open source and is free and is governed by the GNU licensing. So the cost of operation is low, and the ability to add features is very high. And also the packages that are available through the comprehensive R ArchiveNet, it is called as CRAN, are again based on the open licensing. Therefore, there is no cost attached in utilizing any of the packages that are available in the CRAN network. So, on a whole, the cost of operation or the cost that needs to be or the budget that needs to be allocated to R is very negligible as compared to SaaS. And next, when it comes to support,
There's only 2 minutes. Right.
can I continue?
Yes, just continue. Yeah, you can take 2 more minutes.
Okay, so I have two more. You're saying I have 2 more minutes?
Yes.
Oh, sorry. Then I need to rush. Okay, so support-wise, since there is a license bound activity that is there with SAS, then we can we get insurance from SAS that there is a dedicated support. There are defined SLS level agreements where the priority has to be based. But there is no cost involved. Therefore, there is a distributed support and there is a community which provides the extended feedback regarding any kind of issue that is observed during the programming or while setting up a library. Learning resources wise, yeah, SAS and R both provide academic support. So R is freely available and it is widely accepted by the academicians. And when it comes to SAS, there is an on-demand software version which is used by the academicians to learn and understand the technology. So otherwise, as a whole, both the SAS and R provides the capability to generate resource pool that can be used for the regular programming purposes. And when it comes to performance and execution, SAS has the capability to use both in-memory and hard disk utilization. R has got R can use only the in-memory utilization. So if at all there is large data processing that needs to be done, there are certain packages that have to be used for the processing. Otherwise, it is almost the same, and R provides a little bit of additional packages that can be used for performance tuning, and SAS has got the process of providing feedback on the performance, and the optimization techniques can be employed. But both the softwares would be requiring additional hardware if at all there are the jobs or the number of processing capabilities increases. And maintenance wise, it's the same. So both the packages provide sufficient support for maintenance. And when it comes to installation and qualification, R follows SAS follows the industry guidance. Therefore, there is sufficient support that is available from the uh, it has got sufficient support in terms of the IQ, OQ, PQ that can be performed. But R, when it is an open source community, therefore there is simplicity in installation, but it has to follow the guidance provided by the FDA in terms of understanding the accuracy, reproducibility, and traceability to see that these qualification reviews are completed to qualify it for the production issues. So R has got only this limitation of doing a comprehensive validation. In terms of scope, R provides the extended capability. Therefore, there is no doubt about its features. All the features can be extended as much as possible, and using the support-based community, it provides all the flexibility to even create new packages. But SAS bound by the license features, so there is limited scope of extension of scope, and also it can't be integrated with other technologies. And apart from that, if we just look into the usage of SAS or usage of R from a regulatory perspective, so there is a statement that is given from FDA, which says that FDA does not require use of any specific software for statistical analysis. And if at all there is any software package used, then it should be fully documented in the submission. And the process and principles for submitting programs in other languages to the FDA and PMDA are the same as SAS programs. So from a regulatory perspective, R has no restrictions for being used for statistical analysis. And if we look into the rules or guidances that are laid out for submitting the R programs, they're the same as SAS, and like the text file extension has to be provided to FDA, and the R extension have to be provided to PMDA. For SAS, it would be the SAS extension. So the rules for submitting the programs are the same. And if we look into the utilization of R in the regulatory reviews, then we can see that there are multiple areas where it is being utilized. And I'm sure that this is going to be further discussed by Srishal in his upcoming presentation. And from an industry perspective, R gives us more opportunities to collaborate and drive a single purpose. Many companies are using R to support analysis. If we take an example of Novartis, so Novartis is using R and R Shiny platform to develop applications that allow data review and data exploration. In the same way, Roche is building a complete ecosystem for generating TFLs using R packages. So there are other companies which are also using, and if we look into R requires extensive testing for production implementation, and this can be considered as a positive requirement because all the companies can come to an alignment and collaborate in developing common packages that can be used for producing outputs without the further need to validate them again. Like, let us take an example of a frequency table or a descriptive statistics table. The principle behind generating the statistics is the same. Hence, a common library for these modules can be generated and validated once, and they can be reused by any company for their analysis. So this is an opportunity that can be used by the industry. And also, if we take one example of Etaurus, which is one of the company which has made the first steps in building the pilot submission package, it is something which can be considered as industry-wide acceptance is being weighted for the company, and similarly, other companies also can follow the same kind of guidance.